We're going to look at another example of the fetch and execute cycle. This is written in register notation. We have the memory address register, which gets the first location is copied from the program counter. The data and instructions at that location are copied in the next instruction cycle from the memory address register to the memory buffer register, also known as the data register. Remember, the registers are memory locations. At the same time, the program counter is incremented. One is added to the value. Next, the instructions and data that were copied to this location, the memory buffer register, are copied into the current instruction register. The current instruction register is then decoded and executed, and this cycle repeats. Let's have a look at this example. Program counter, memory address register, memory buffer register, the address bus, these are the wires, and the data bus coming from main memory or immediate access store. This is the RAM, and this is the CPU, the processor. We have the current instruction registers, the opcode, the operand, will decode it, arithmetic and logic unit, and then the accumulator. So program counter is at 0. So we copy 0 into the memory address register, then the data runs along the memory address bus to memory location 0. We then will load the instructions, which are LDA6. This is telling us to load into the accumulator the data that is at memory location 6. So we copy these, we increment the program counter, and we copy this data into the memory address register. We now copy the opcode into the current instruction register and the data into the current instruction register, and then we execute that. And when we execute it, it's asking us to load the data at memory location 6 into the accumulator. That's what this instruction is saying. So then we take the number 1 and we put it into the accumulator. That's another brief example of the fetch and execute cycle.